Okay, so you can make a cheat sheet for the exam, one side of a piece of computer paper or graph paper. Put as many formulas, hints, whatever you want on there. So as you go through this review, I would be writing down formulas. If you don't know how to do one of these things, write it down and put it on your cheat sheet. So you have to know how to define a number, like what classify a number. So negative square root of 5 is definitely a real number. It is irrational because the decimal for that one does not ever end. It doesn't have a pattern to it. It's a real and irrational number. So both categories need to be there. 5 is also real, but it is rational. You can write it as a fraction, for example. So rational numbers are fractions. So 5 over 1 can be written as a fraction of integers. It is, let's see, what else is there? So rational, real, natural. So technically this is a natural number. So that's like a counting number. Like they start at 1, 1, 2, 3, 4, 5. It's a whole number. Those start counting at 0. So 0 is a whole number. And it's an integer. Integers are positive and negative. So if you had a negative number, it's an integer, even if it doesn't have a decimal. If it doesn't have a decimal. So wow, falls in a bunch of different categories. Square root of negative 5 is different than this one because the negative's inside the radical. So this one is not real. It's actually just imaginary. I don't think I had that on the list, but I put it on there. Just you should know that. Imaginary numbers. Okay. By the way, a little note to self, little star means you can use TI-Nspire. So in these questions with stars and those sections, you could use your Nspire. Of course, I don't know if your Nspire is going to help on that one, but some of these are well. So you could use your Nspire on this question. So if you want to, you could. You're plugging in a value of x equals negative 2 for x. When you plug in, be sure to plug in with parentheses. So negative 2 squared is 4. 4 minus 3 is 1. So the key thing is there you're squaring a negative, and so your answer is 1. So some of these could have an infinite number of solutions. If you get somewhere where you get like 4 equals 4 or something, that's going to be an infinite number of solutions. You might get no solutions. If you get something like 4 equals 0, you'd be like, wait a second, that doesn't work, because sometimes the variables tend to go away sometimes of some of these equations. So let's just distribute use distributive property here. So this would be 10x minus 6, minus x equals 9x minus 6. I don't know if this will work or not. So this would be 9x minus 6 equals 9x minus 6. You might just be able to stop at this point. You might know what the answer is. But if you don't, let's subtract 9x from both sides. We get negative 6 equals negative 6. That's a case of something equals that's an infinite number of solutions. So infinite solutions there. If those two numbers were not equal, it would be no solutions there. Sometimes you get an actual solution. I'm not saying it's always one of those. Solve the equation for the variable for r. So this is just a one-stepper. Always try to add or subtract first. So you get r equals c divided by 2 pi. Don't worry about simplifying those, just solve them for the variable that's specified. So solve and graph a linear quantity. So graph on a number line. So this is on a number line type of graphing. So let's just kind of solve this if we can. So I'm going to subtract 6x. So I get negative 3x less than 12. Divide by negative 3. Now remember, when you divide by negative, what do you have to remember to do? Switch the direction of the sign. So x less than negative 4. So on a number line, negative 4. Open circle at negative 4, arrow to the left. Be the graph of that. This one, when it has like in between there, so I'm going to subtract 2 from each kind of like, there's almost like 3 parts to this inequality equation type thing. And so we get 1 greater than y greater than negative 2. So on a number line, so those are both, oh wait, greater than or equal to, sorry, this is greater than or equal to, okay. So -2 should be a closed circle because of the equal to sign there, and at 1 it should be an open circle, and everything in between should be graphed. Solve these just separately. There's an OR statement between. We'll do that with it in just a minute. So subtract 7, so we get 3x less than -6. Divide by 3, you get x less than -2. Or add 3, you get 2x greater than 4. Divide by 2, x greater than 2. By the way, I didn't have to switch the direction of signs because I didn't divide by negative there. So -2 and 2. Open circle. Open circle. I don't have to worry about the overlap on this one. If, remember, like sometimes you get graphs that when you kind of graph the, kind of looks like this. And if it's an and statement, you're looking for just the overlap there. Does it kind of make sense? Like so you would not draw the arrows, you would just draw the overlap. In this case, both of those are solutions that go out kind of like wings with an OR statement. That happens quite often. Absolute value, you want to isolate the absolute value. Let's add 4 to both sides. X plus 3 in absolute value equals 9. Separate out into a positive and negative case. So x plus 3 equals 9. And x plus 3 equals 9, where one side is the opposite of what it started. So this would be x equals 6. That's one of my solutions. And distribute the negative, you get negative x minus 3 equals 9. That's a 3. Negative x equals 12. X equals -12. It's negative right there. This one, you want to split it up into a positive and negative case. So we get 2x plus 1 greater than 7. And the negative case is, I kind of put that over here, 2x plus 1 greater than 7. So let's solve that. You get 2x greater than 6, x greater than 3. This one you get -2x minus 1 minus 1 greater than 7, so -2x greater than 8. Divide by -2, so that does switch the direction of the sign. And remember, this is what we call a greater statement, greater. So it's an or statement between these two. If that was less than, that would be an and statement. So or. So if I were to graph my answer on a number line, x greater than 3 or x less than -4. So you can probably picture that in your head. So greater than 3, open circle at 3, arrow to the right, open circle, -4, arrow to the left. So something like that. Vertical line test, evaluating a function. So, okay, so is this a function? So all the x's are not unique, right? So this x of 1 has an outcome of 2. This x of 1 has an outcome or an output of 1. This is not a function because each unique x value needs a partner. And so you have one input, one output when you have a function. That would not pass the vertical line test. If you did graph that, it would be like 1, 2 would be like there, and 1, 1 would be there. Those 2 points are completely vertical from each other, so those are not part of a function. You probably know how to do this. Just plug in -3 everywhere there's an x. Do order of operations, so 2 times 9 plus 1, so 18 plus 1, which is 19. y equals 6 when x equals 2. So identify. So direct variation. So this is assuming this is direct variation, which the formula you need, I would definitely write this down as y equals kx. So let's plug in what we know, plug in those two values. So we get 6 equals k times 2, divide by 2, you get k equals 3. Write the equation. So the equation would be y equals 3 times x. Identify the constant. That's that. This is the function rule, or sometimes we could just call it the equation. The function rule is this guy. Graph on linear equation, slope-intercept form, slope form. So really, we really like this to be in slope-intercept form. So let's do that. So let's add x. So we get 2y equals x plus 6. Divide by 2, you get y equals 1/2 x plus 3. So y-intercept of 3, slope is 1/2, positive. Make a bunch of slope points. I only provided one graph, so we're going to do this graph on there as well. So this is going to be a vertical line whenever it's x equals y because it's horizontal. So it's going to be a vertical line like this. This one you definitely want to solve this for y. So we get -2 if we subtract 3x. And let's go ahead and add 8. So we get -3x plus 8 divided by -2. When I do that, I typically divide each term by -2. Okay, so -4, 3/2 up 3 over 2, up 3 over 2. That's enough points. Graph your line. Find the slope of the line containing these points. So slope formula, you need to know that, is y2 minus y1 over x2 minus x of 1. So this would be 3 minus -1 over -2 minus 4, which is boom, boom, 4 over -6, which is -2/3. Find the equation line. So I think we need to do the slope first. Let's find the slope. So m is going to equal -2 minus 0 over 5 minus 0. So this is -2/5. The y-intercept is this. So in this case, we can just carry the y-intercept to 0. So my equation is y equals -2/5, mx plus b, -2/5 x plus 0 is the y-intercept. So that's your equation. Otherwise, we would have to plug in and find b if they didn't give us the y-intercept. So this one has a slope of m, goes through the point there, find the equation. The fastest way to get that, if you know y minus y1 equals m times x minus x of 1. So I'm going to do it the fast way. So y minus 3 equals 1/2 times x minus 2. That's the fastest way of writing your equation using point slope formula. Find the equation line perpendicular to that one. So this one would be y equals -x plus 5. So the slope of this one, m equals -1. So the slope of the perpendicular would be the opposite reciprocal. So I flip it, that's just -1, and I change the sign to +1. So slope, perpendicular slope, just so you know it, is the opposite. That means change the sign. Reciprocal means flip, reciprocal. So I know the slope of my new line is this. I know it goes through that point. Find the equation. The fastest way to do that, y minus 5 equals 1 times x minus 0. Fast. How to graph absolute value equations. So you know you're starting with the points you know and love, 0, 0. For absolute value, it's 1, 1, and be careful, this is 2, 2. and negative 1, 1, and negative 2, 2. And multiply all these by a equals negative 1, so this is going to be 0, negative 1, it's going to change signs. We'll plot those 5 points. So I'm going to plot, let's see, 0, 0, negative 1, negative 1. There we go. Okay, this one goes to the right 2 units and down 3. So every point is going to go to the right 2 units and down 3 units. That's the vertex. To the right 2 units, down 3. To the right 2, down 3. And move those as well. Pretty soon you've got your graph. Absolute value inequalities. So this one, oops. So again, if you know your points, you get an a value of 2 there. So 0, 0. Sorry. 1, 1. Sorry, my computer's doing some weird stuff. I may have to restart after this problem here. So I'm going to multiply, so a equals 2. So I'm going to multiply all the y values by 2, so you get 0, 2, 4, 2, and 4. So to plot those points, 0, 0, 1, 2, 2, 4. Oops, sorry, I missed that point. Let me see if I can redo that. There we go. You got those 5 points there. And then this is going to move it down 2. So every point goes down 2. So that's my new vertex. This point goes down 2. This point goes down 2. And you've got it.